All right, this is number 31, chapter 3. And how I'm going to do it here is, first of all, we're going to read the problem. So, the problem says, Ruth sets out to visit her friend Ward, who lives 50 miles north and 100 miles east of her. So Ruth is here, and we're going to go up 50 miles and over, is it 100 miles? And over 100 miles. This is where her friend Ward is. And this is Ruth right here. And then she starts by driving east. But after 30 miles, she comes to a detour. So she goes east for 30 miles. And then she takes a detour that takes her 15 miles south. So then she goes 15 miles south. Before going east again. Then she drives east for 8 miles and runs out of gas. And she runs out of gas. All right. So Ward flies there in a small plane to get to her. What is Ward's displacement vector? We want it in component form, and we want it as a magnitude and direction. So what we really need to find is that vector right there, because this is Ward. He's going to fly his airplane to this point. He needs to know what direction to go and how far to go. So to do that, we have to figure out what that vector is. So this is the one we're going to look for. We're just going to call this a vector V for what we're trying to find here. All right, the easiest way to do this is do this as a whole series of vectors. Notice that I can call this vector, let's call this vector A, this vector B, this vector C, this vector D, and this vector is E. Then the easiest thing to say is, look, if I follow this, I go A plus B plus V. That gets me to this point right here. Boom, boom, boom. But that has to be equal to C plus D plus E. Because if I add those three together, they get to the same exact spot. So now I've made it into a vector equation. And then, what we want to do is we want to figure out vector V. So I'm just going to solve it for V. I'm just going to say, oh, well, V then is equal to C plus D plus E minus A minus B. And remember, I have to do that twice. So I'm going to do this for X. And I'm going to do the exact same thing for Y. So it's going to be CY plus DY plus EY minus AY minus BY. And that's how I'm going to figure out the vector components. But to know that, I have to know all the vectors. So up here, I'm just going to figure out what all the vectors are. So for vector A, AX is equal to 0, because there's no X component. But AY is equal to 50. BX is equal to 100. BY is equal to 0. CX is equal to 30. CY is equal to 0. dx is equal to minus 15, minus 0, dy is minus 15. Because you look, it's going right this way. And for vector E, ex is equal to 8, ey is equal to 0. So the components are very easy because most of them, in fact all of them except for V, are right along one of the coordinates or the other. So they're either x or y. So now I just can plug all that in. So Vx is going to be equal to Cx, which is 30, plus dx, which is 0, plus 8, minus 0, minus 100. And that gets me Vx. And Vx is going to be equal to negative 62. This is miles. And over here, Vy is going to be Cy, so Cy is 0, plus negative 15, plus 0, minus 50, minus 0. or Vy, is going to be equal to minus 65 miles. All right. Then they want us to write this in several forms. They say vector notation. We can write this as V is equal to negative 62 I hat minus 65 j hat. Is one way to write it. But they also want us to figure out what is the magnitude and direction so we can fly his airplane there. Well, to do that, we have to figure out the magnitude, which is how far he goes. And that's just going to be the square root of 62 squared plus 65 squared. You take the square root of that, and you get that he had to fly his plane 89.8 miles. But I think we only have two sig figs, so we're going to round that to 90 miles. And we need a direction. So for here, so if I extend this, this is Vx, this is Vy. So I want this angle right here. So I'm going to use the inverse tangent. But remember, tangent is always opposite, so opposite on this one is Vx. So Vx is equal to negative 62, so I'm going to do the inverse tangent of 62. Remember, I always ignore the signs, take the absolute value, 62 over 65. And when I get a direction angle there, I'm going to get 44 degrees. And that's going to be 44 degrees west of south. Or you could have flipped it the other way and said it was 46 degrees south of west. Now, if you're actually a pilot, an airplane pilot, they measure their things in what's called heading, where north is equal to 0, east is 90, south of 180, west is 270. So when air traffic control tells them what to fly, they give them as a heading. In this case, we would have 180 plus 44, or they would fly a heading of 224 degrees. That way, they don't have to say south of east and west, and you're not figuring that out in your cockpit. You just say, oh, heading 224, you just dial your plane until 224 comes up on your compass. And that's how it works. So that's how you do number 31, chapter 3.